Hello everybody. In today's video we're gonna have a look on logarithmic functions, graphs and properties. Before we do, we have to start with the exponential function, which is defined this way, and we already know that the graph of this function depends on the value of the base, which means if a is greater than 1 or a is greater than 0 and less than 1, there are two graphs. So in this case our graph looks like this, and the function is increasing and passes through the key point with the coordinates 0 and 1. And in the second case the graph looks like this. The function is decreasing and still the graph passes through the point 0 and 1. During my previous video I said that our logarithmic function is defined by the equation y equals log base a of x. And as you can see, and you already know, this is the inverse function of exponential function. Everything what is important in these two functions concerning the properties is the base. Okay, we know already, and you could see it in the previous video, that to find the graph of logarithmic function, which is inverse of the exponential function, is to find the key point, which is here, and its coordinates are 1 and 0, and then this part of the graph will be flipped and this part of the graph will be flipped, and our final result will look like this. Okay, so if you consider this green line, which is represented by the equation y equals x, as a mirror, and you look into the mirror from point of view of the exponential function, you should see in the mirror the picture with which is represented now with the blue function, and its equation is y equals log base a of x. Okay, so as you can see, and I will summarize the properties of this graph later on, but the exponential is increasing and logarithmic function is increasing as well, though what have changed is the domain and the range, but this is normal for inverse functions. Let's have a look what will happen with in the second case. And again, if you would have a look into the mirror, you will realize that this part of the function will be flipped like this here, and this part of exponential function will be flipped like this here, and again the key point will be defined and will have the coordinates 1 and 0. What is important to note and say, for the exponential function we have horizontal asymptote, and for logarithmic function this horizontal asymptote again was flipped over the line y equals x, and it became now the y-axis. So for logarithmic function we have the vertical asymptote, which is defined by the equation x is equal to 0. Okay, this is a very important thing, and the same applies for exponential and logarithmic function if the base is less than 1 but still greater than 0. Okay, so the black line is exponential and the blue line is horizontal, and as you can see, our key points changed their xy coordinates, and the asymptotes became like from horizontal, it became the vertical asymptote. Okay, as you can see, horizontal is now vertical. The same applies here. And just to summarize, the equation was y equals 0, and okay, let's do it like this. Here the asymptote is y equals 0, and here also y equals 0 is the asymptote. Okay, so now let's have a look on the properties of our logarithmic function. Basically, you can see the domain of the function. Okay, let me do it in blue. The domain of logarithmic function is equal to the interval from 0 to the infinity. It's the same as it was the range of the exponential function before. This we already know. Then the range of the function is the range is all the real numbers. Okay, because as you can see, the line goes from the negative infinity to the infinity. Then if a is greater than 1, if a is greater than 1, then the function is increasing. If a is between 0 and 1, then the function is decreasing. And what else? The function has no mean, no minimum, no maximum. So we can say no extremas. In general, it's unbounded. It is a one-to-one function. But it's not odd, and it's not even, and of course it's not periodic. Okay, and as we said, there is a vertical asymptote, which is defined by the equation x equals 0. What is really quite important for logarithmic function is this key point. Okay, so it always passes through point 1 and 0. This point is really like important. Okay, this is the same point as it was for the exponential function. Okay, so the most important thing, or the most important information from this video is to be able to sketch the graph of the logarithmic function based on the value of the base. So let's do some or a couple of exercises. Very easy one. So let's sketch the graph of the function y equals log base 4 of x, and then let's sketch the graph of the function y equals log base 1 over 2x, and let's see the difference. The main thing is as a is greater than 1, which means 4 is greater than 1, so the base, we know the function will be increasing, and it has to pass through the point 1 and 0. So what is most critical? You sketch this point, and then you simply sketch the graph of the function, and this is our function. Okay. In the second case, as we already know, a is greater than 0 but less than 1. The function, which means 1 over 2, is less than 1. It means the function will be decreasing. So let's sketch the graph of such a function. Again, key point is here, which is 1, 0, and the function will look like this. Okay, good. So this is the easiest way how to sketch. If you can't remember how the function looks like, you start with the exponential, you then do the inverse, and then you are done. Okay. Let me do one more exercise to just show you what you already, in my opinion, know about the transformation of the function. So if you would be asked to sketch the graph logarithms base 2x plus 1, or function y equals logarithm x take away 2 1 with the base 1 over 2. So this is kind of transformation you already know how to apply. So you start with the function log base 2x, which is the parent function in this case, and it must pass through the point 1 and 0. So this is my parent function, and now we already know that plus 1 means you transfer the graph 1 point, you shift the graph 1 point to the left. So basically our new point will be here, and also be careful because our vertical asymptote will move also 1 point to the left, so it's gonna be x equal -1, and my graph will look like this. Okay, and you take the same procedure for the graph on the right side, which means you start with the parent function if you want to, and it's gonna pass through again the point 1 0. Now it will be shifted 2 points to the right, so it will pass through the point 2 points to the right. So this is my critical point, and also my asymptote will be shifted like 2 units to the right. So this is gonna be my graph, my horizontal asymptote, and the final graph then will go behave like this. Okay, so the blue line is the function y equals log base 1 over 2 of x take away 2, and here my blue line represents the function y equals log base 2 of x plus 1. Okay, now I'm pretty sure you should be quite familiar with the logarithmic functions, and you are ready for more complex tasks. So let's do some training, and thanks for watching. Bye.